We'll start with we have already discussed plate movements and the reasons behind movement of plates. Any question if you guys have?
Sir, how the shape of plate do changes?
Shape of plate?
Also changes due to convergence or divergence or
Both, because of the combination of factors. Because within the intraplate there may be some subsidence. On the convergent boundary there will always be change in shape of the plate. Because the subduction takes place and there will be bending.
Apart from these two factors influencing
No. Right? Now the theory of plate tectonics. Now it uses again convection current theory in a more scientific way. To explain the movement of the plate. It says that the lithosphere is cracked at several places. Along the line of the fissure eruption. Making or dividing the lithosphere into several plates. Each plate is moving independently along the transform fault, that is conservative margin. The movement of the plate has several consequences, not only along the margins but also away from it. This is explained by plate tectonic theory very scientifically and has the widest possible acceptance among the present discourse related to geomorphology. Here is the intro part. Whenever you want to write plate tectonic theory as a holistic feature, but whenever you have a question regarding complete plate tectonic theory, it's the most unified theory incorporating not only the distribution of the first order landforms but also the crustal features within the volcanoes, the earthquake, the islands, and even the minute details of these features. This way, it has simplified the complex concepts of the geomorphological features with the help of plate movements and related consequences. If the question is about historical perspective, most unified, so in one go it makes many theories redundant, obsolete, including the idea of continental drift. Both Taylor and Wegener, the sea floor is spreading and various theories of mountain building. It suggests three types of movement. That is divergent boundary or constructive margin. Convergent boundary, destructive margin. Conservative boundary, passive margin. Now the divergent boundary. This boundary is formed along the rising column of the magma, forming fissures. This is a funnel shaped depression reaching till the asthenosphere. Initially, the magma rises to form discontinuous rift valleys, which gradually joins to break the plate or the lithosphere into two segments. Present example is the mid-oceanic ridges of all the oceans. Along the Rift Valley, magma rises to push the plate apart or away from each other. Thus the divergence of the boundaries. The upcoming magma is deposited along the marginal side of the plate to make new young crust. Hence the constructive margin. The common area of such divergence is along the oceanic crust. However, it may happen within the continental within the continents as well. Which is known as continental rupturing. Rupturing. Rupture. Oceanic plates are thinner, hence the common or more pronounced areas of divergence. When the magma is deposited, along the side walls, they rise up slightly to form the ridge or local mountains. This is called mid-oceanic ridges. Because they will be located in the middle of the oceans. Even in the case of continental rupturing. Along the continent, it pushes the continent away to form new oceans, popularly known as opening of the sea. This way, it explains not only the formations of the mid-oceanic ridge, but also the distribution of the oceans. Hope we understand this part, right? It's very easy to understand. That's how the continents, let's suppose a continent is being broken, right? So the magma will be coming up here, gradually it will be making the continents to move away from each other. Now that's the best example of the present opening possible is the East African Rift Valley, right? You can give example. For example, East African Rift Valley is the best present example where Rift Valley is being the longest rift valley on the surface of the earth presently. I hope you guys have atlas with you, right? Open the atlas and look at the rift valley of East Africa.
Sir, in the first paragraph you have stated, usually the magma rises to form this rift valley, which gradually joins to break the plate.
That's what I'm explaining here. You look at the East African Rift Valley. This is not like one go phenomena. It's a very gradual, slow process. That's why we call it slow movement. Chai bhijwa dijiyega, please. Like look at the Africa, physical Africa. You can see there. That will be that giving you a better, clear picture. You don't have atlas with you. A very bad idea to sit in the class of geography, right? You can sit with. Come, sit here. लड़ाई शड़ाई तो नहीं किया ना अभी तक? अभी तो जस्ट बात ही नहीं हुई है. Okay. This is Akshita, right? Pragya, okay. So introduce yourself. You each other both and sit together. Both of you introduce each other and then sit.
I'll just tell my name.
Okay.
Introduction gives long subjective scope.
Where you may have maybe criticized by me, right? Because you have left this, you have left that. So instead of going through the tortuous round, just look at the Africa. Now look at here. You have few rift valleys, starting with Lake Malawi. You can see that on the south, Tanganyika, Lake Tanganyika, Rudolph, Turkana. So they are scattered lakes, right? Red Sea is very much within this rift valley. Then along Gulf of Aqaba, it reaches up till Dead Sea. Now this is not a continuous rift valley yet. It is evolving. That's what the geologist and the scientist believe, that this is evolving into a full-fledged divergence zone. So there will be discontinuous lakes, there will be discontinuous rift valleys that will gradually be joined to form a single elongated rift valley, and thereafter it will be broken into two parts. And that's why it is believed that Africa is being split into two parts.
So is there a mid-oceanic range between the Red Sea?
This will not be forming right now. Mid-oceanic ridge will be formed. Now imagine.
Initial stage.
Yes, it is the initial, very in fact. Now imagine what will happen. Look at the continent level. So when the rift valley is being created, once it is created, the magma may not be able to reach till here. So what the magma will do, once they join together, the magma will start pushing the continents away, right? The moment continents are broken and pushed away, what will happen? The ocean will enter into it. Opening of new ocean, formation of new ocean. This is purely a continental area. After a point of time, this will be transformed into an ocean. Initially, ocean will be very narrow. Thereafter, once it is continuously pushing the continents away from each other, now the ocean will be widened. And the moment ocean water enters into it, now the magma will be taking place under that ocean water. So even in that case, if the rate of the movement will be roughly equal, so that ridge will be formed below the ocean water. The deposition now is under the ocean water. So once the continents are moved away, that will remain at its own position, that is in the middle of the ocean. That's what you call mid-oceanic ridge. So even in the case of continental rupturing, the mid-oceanic ridge will be formed, new ocean will be formed, and that ridge will remain in the middle of the ocean. No, Madagascar is a different entity, like formation of islands in the middle of the ocean may be associated with a different thing. Maybe a broken part. Like for example, if you have Japan or other islands like Azores, some may be volcanic island, some may be tectonic island. Like if Africa is being split just like this, so it will not be perfectly splitting. There may be some patches which might be broken, and that might get detached from the East African part or the West African part also. So that will appear as if a single island. Whenever we break, and breaking of the huge continent, that 200-kilometer thick lithosphere, so it will not have a perfect split, and the carving out or the cutting may not be perfectly edged. So there may be some scattered islands also in the breaking process.
So Red Sea is a resultant of this type of.
Red Sea is
a resultant of this type of process.
exactly the process of rifting. That's why Arab part is a small plate, the Arabian plate. If you look at the last page of the plate boundaries again, last page which explains disaster. That's page. That's the page, Rohit. What is the page number? 114, no? 104. Look at 104 page, Knox 4D student, and you will see the small plate right there in African area also. That is Arabian plate. So there are 6 major plates and more than 20 identified plates. Somewhere it is written 7 also, but primarily it is 6 only, because whenever it is 7, they will divide North America and South Africa into 2 different plates. But generally these are both are treated together as an American plate. Pacific plate is the largest and perhaps the only purely oceanic plate. Rest of the plates are oceano-continental in nature. Pacific, African plate, Eurasian plate, Indo-Australian plate, Antarctic plate. There are 6 major plates. And then look at lots of minor plates as well. Nazca, Juan de Fuca, and then Arabian plate. Look at the eastern side of Philippines. Around Philippines, you have good number of small plates. And the site of divergence, you can see all the site of divergence. Mid-Atlantic ridge, Pacific Ocean ridge. Look at the Indian Ocean ridge also. That will be dealt when we are discussing about the ocean bottom relief. So here itself you can almost finish the ocean bottom relief also. Indian Ocean, it's not, it's about Atlantic. It is the Atlantic is widening, Pacific is shrinking.
If this Red Sea opens up, it will be
So look at Nazca plate, Cocos plate, Caribbean plate, Juan de Fuca plate. Cocos plate is the most widely studied plate, and there you have the triple junction. Any question?
So why that Pacific ridge is not exactly in between?
That's what it's, the term is basically mid-oceanic ridge. Does not necessarily mean it will be perfectly in the middle of the ocean. Why? It is basically along the American coast, right there you have convergence. So it is not in the middle basically because convergence is lying on one side very small, and that's one of the criticism of plate tectonic theory also.
So can we say that example of paleomagnetism being ruled upon?
No, paleomagnetism is something different. Sorry. Paleomagnetism is different than this. Paleomagnetism is one way to prove the existence or presence or occurrence of the divergence.
So it depends on the age of the ridge also. Like if it is initial age, it will be in the middle of the ocean.
No, if it is a continental rupture, just for example, let's say East Africa. Now look at here what is happening in Africa. Africa is sinking under Eurasia. So Mediterranean Sea is shrinking. So not only the creation but also disappearance of the oceans are also explained. So we'll talk about disappearance of the ocean when we are talking about the convergence. Right. Now look at the problem here. In the case of Africa, Africa is moving northward, right? And a part of being split. Now the moment it splits, there will be a problem because you have middle of the Indian Ocean also showing ridge. So that ridge and this ridge, there is no proper convergence here right now. Convergence has not evolved. So how this plate will behave in the future is unknown to plate tectonic theory. Because between two divergences there must be a convergence. And once the East African Rift Valley is broken, and here Indian Ocean is also broken, in between this will be a single plate. What will be the direction of this movement? Right. That depends upon how this ridge is being connected to different parts of the ridge.
Sir, if we read the convection cells in the Atlantic Ocean, they if we cell which is the region of divergence, then there should be a subduction also.
Yeah, that subduction is there.
Then how it can depart, like how it can diverge? If we say cell, are there like different type of cells in the whole interior?
Cells are started with the first the fissure eruption.
Sure.
Now imagine that a new fissure is being created. So the magma will be formed here only first. So once it starts rising through finding out or creating its own path, it will keep on trying to find its own path. But the moment it has reached close to lithosphere, then it's not just in one day it will evolve. So it will hit and it will start finding out its own path along this. So convection cell creation itself is associated with the rising column of magma. Right, and that's the inability of the plate tectonic theory. Once we finish it, we'll discuss about that.
Basically, the movement of the convection cells within the surface, the direction is not studied yet. So we don't know in which direction.
No, direction is studied, and direction is reflected through the direction of the movement of plate. But it is very complex. It's not so simple the way we are discussing, because things happening under the lithosphere is not very properly well known and properly understood. So when the magma is rising, it is creating rifting. That's fine. When the magma is moving, now initial creation of plate is there. So it is started moving, pushing it away. So there may be proper convergence and there may not be proper convergence. The rate of convergence differs in different cases. So if the rate of divergence is similar along the mid-oceanic ridge, how can the rate of convergence be different? And if it is different, there is no explanation for that. Again, it's basically about the inability to understand what is happening inside the lithosphere.
We can say the movement of the plate is actually associated with the convectional cells direction.
That's why Arthur Holmes' theory is just a part of it.
Yeah.
It's not a complete and very well explained theory, because the magma may not be able to make a complete proper cell. Right? So because magma, if it is making a complete, that's what defined by plate tectonic theory. There is no need to have a cellular motion of magma. So that part will be discussed in convergence. Yeah.
So why this Cocos plate is widely studied?
Because it is American area, NASA and all. That's what they are doing. They are very close to, in fact, coming out with the identification of the exact timing of earthquake. They are studying for that. that can earthquake timing be, exact timing be expected or foretold.
And it is trijunction of what?
Trijunction of plates, triple junction, that's what you call triple junction. 3 plates are converging there. If a small plate is surrounded from 3 sides by other plates, that's called triple junction.
And so what are knots? Knots, Pamir knots and knots.
Pamir knots are within convergence of the mountains. If you look at Pamir knots, you have the Himalayas, then Tian Shan, Kulnun, then this side also, then Suleiman and Kirthar. That's what you call knots. From where different direction mountains is moving or spread. Sorry?
So we can say it as a junction point.
Junction, yes. Mountain junction is the knot and plate junction is triple junction. Convergence. Now, when the 2 plates move towards each other, it is called convergence or convergent boundary. Along the convergent boundary, the plate collides against each other making lot of sedimentary rocks. Through the destruction of the marginal parts. Of the plates. That's why it is also called destructive margin. The compressive forces generated along the convergence pushes the sedimentary deposition upward in a wave-like structure. One of the plates along this line moves downward towards the mantle. Along a zone called subduction zone, as the process is known as subduction. the subducting plate experiences increase in temperature because of the frictional force, or because of the friction and depth. This causes melting of the plate or melting of the subducting plate to produce huge mass of magma. These newly formed magma pushed upward because of the density differentiation or force of buoyancy. The rising magma pushes the non-subducting plate upward, resulting into vertical rise of it along the rising line, along the rising not line, zone. Now imagine when the plate is converging, this is the line of convergence, right? Once they are coming, they'll be forced to, one will be forced to bend and move towards the mantle, right? This will be gradually pushed downward. Here you will have good amount of sedimentary rocks formation. Now imagine it is continuously being pushed. So what will happen? There will be gradual increase in the depression. This depression will keep on being increased. So that's depression. Then here along this line, huge amount of compressive forces, sediment formation, will be a common phenomena, though with different intensity in different type of convergence. Once this plate is moving down, it will keep on moving down under the influence of its own weight and velocity, or rather momentum. Each movement will be movement associated with a jerk, because this moving mass has to displace the rocks of the mantle, directly explaining the occurrence of earthquake along the convergent boundary. नहीं, मुझे भी समझ में नहीं आया. समझते हैं मिलके, हाँ? First thing, convergence, I hope we understand, right? Whenever two things comes, let's say suppose I'm bringing this chair, if I can, now imagine these two are converging, right? Or imagine this is happening under the ocean waters. Let two items of differing density move under the water with maybe similar speed or different speed, but the momentum will be different. Momentum into is equal to mass into velocity. So the item which is heavier and the item which is lighter, let them collide. So the lighter will be forced to rise upward and the heavier will sink in the bottom. Right. Now since we are talking about the independent items here, just imagine these items is huge in size and connected just like a plate in the earth. So when they are colliding, initial collision will be along the tangent of the sphere or the circle. Let's say earth has a circle. So what will happen when it is converging? It will push against each other. Thus the marginal part will experience lot of destruction, producing lot of sediments. Now it is being pushed away from the divergent boundary. So what will happen? Gradually one which is slightly heavier or denser will start sinking, moving down. So now it is not only moving under the influence of compressive force, remember it. So when it is moving, it will hit this part also. It will generate a lot of pressure along the marginal part. So this will further produce sediments. And now when it is pushing it, obviously the depth of this will keep on increasing and it will keep on moving also. It's a very slow movement, right? The moment it is moving, it has to displace the rocks of denser intensity or denser rocks. Why? Because these are basically lithosphere. Among the lithosphere, the varying density or the higher density will be moving down, but the area which it has chosen to move down or subduct is the area of higher density rock because they are mantle. So the lithosphere will always be lighter as compared to asthenosphere. Look at it, there are two parts. Very often students get confused. When I am talking about this is how higher density will sink, it's a relative term with respect to this plate. When I am talking about this is moving into the denser medium or denser rocks, I am talking about the mantle and the crust or the lithosphere. So when it is moving, initial movement will be resisted a lot, right? But under its own weight and velocity and being pushed away from the ridge, it will keep on moving down. The moment it is moving in the interior of the earth, what will happen? It has to keep on displacing. So the chances of its movement will keep on decreasing if it is moving in the interior. So the resistance will keep on increasing, and the resistance will keep on increasing the temperature of the plate also. Besides, the depth will also result into higher temperature, and because of that, the part of the rock will start melting, right? The moment it starts melting, it has lost its initial edge of movement, right? Now this molten material is of this lithospheric plate, which is lighter as compared to the surrounding rocks. So the buoyancy will be much faster than the normal magma. Is it clear or not? Because here what we have generally discussed about the formation of magma in the asthenosphere is associated with the melting of the rocks of mantle, which is relatively denser, and it is moving. It has been made and moving out of the zone of the similar density, but since it is liquid, it has to move or relatively have lost density, so it has to move. But in this case of the magma which is formed under the lithosphere is made up of much lighter minerals, made up of lithosphere. So the upward push will be very, very hard. Right? Now, everywhere when it has moved, so everywhere magma will be formed, all along the magma will be formed. Right? So magma will be rising up, and when it is rising, it will keep on pushing, uplifting the area. That's how the vertical growth of the mountain takes place along the convergent boundary. The compressive forces, which is horizontal in nature, can cause initial folding, can cause to rise a bit under the influence of compressive forces, but cannot make a huge mountain like Himalayas or Rockies or Andes. So the rise, vertical rise, like हम कितना भी इसको प्रेस कर दें, 1 सेंटीमीटर उठा सकते हैं, 2 सेंटीमीटर उठा सकते हैं बीच में, right? But if it is rising like this, it has to have a vertical component. So that vertical component is generated by the magma which is produced below that structure. And if it is folded and fold mountain, it will keep on rising, or whatever structure is formed along this will also be moved upward, this will also be moved upward. That's why every mountain is associated with a plateau.
And the Himalayan region has the core made up of igneous rocks. That is the reason.
That's the reason. Igneous rocks, base will always be igneous rocks.
Mountains have sedimentary.
That's the most mysterious aspect of mountains, which was not explained till the plate tectonic theory, has been explained by this theory. The occurrence or the presence of sedimentary rocks on the top of the mountain, because sedimentary rocks are produced because of the exogenetic forces, and the exogenetic forces are occurring below the mountain, like much below the height of the mountain. Let's say Mount Everest, and presence of sedimentary rocks on the top of Mount Everest. How is it possible? That can be formed only when it comes down. So the sedimentary rock formation is much below than the top of the mountain, and if the top of the mountain has thick layer of sedimentary rocks, that was the most complex thing to explain for the scientist. When Humboldt was visiting in the Andes mountain areas, he was very perplexed with this, that how come the sedimentary rocks are, that too a very thick layer of sedimentary rocks are present on the top of the mountain. Getting that? So now the initial sedimentation is associated with the collision of plates, and the sediments are formed. It may be added by the continental exogenetic forces. Suppose if the rivers are coming from this area, that may be added, but initial sediments will be associated with the collision and the compressive forces of the two plates, and now that sediments will be compressed and wave-like structure will be formed. Now this is the common consequence of almost all the convergence. There is a subduction, a depression formation, a wave-like structure, then upliftment of the area. Yeah, come.
So the earthquakes will always be on the subducting plate.
Not always. Look at it. That becomes very straight statement. But the convergent boundary will always be associated with earthquake of different magnitude, different intensity, and different depth also. That's what we call tectonic earthquake. So convergent boundaries are the site of earthquakes.
So can we say that endogenetic forces are more active than exogenic forces?
Where?
In case of mountain.
Yes, obviously the formation of a tectonic mountain or fold mountain is primarily, fundamentally, and in fact only the result of endogenetic forces.
The sediments
Formation, that is a process of formation of a mountain, a fold mountain or a volcanic mountain is purely exogenetic in nature, endogenetic in nature. But the landforms found in the mountainous region is a combination of endogenetic as well as exogenetic forces. That's where when we discuss the cycle of erosion or slope evolution, or for that matter even channel morphology, meandering in the upper area of वो यहाँ पे सारे इंफॉर्मेशन वो काम आएंगे. Antecedents of rivers, how the antecedents are formed. So we'll correlate this. That's why a proper understanding of plate tectonic theory is not only necessary to understand the various features, but also to understand the other parts of like slope evolution. So it will be very handy when we discuss about that rise of the mountain. Like for example, Davis has suggested that erosion starts only after the upliftment. Right? Completion of the upliftment. Penck suggests no, both goes hand in hand. So it is easy to understand when you visualize plate tectonic. You can refer plate tectonic theory. You can name plate tectonic theory, how plate tectonic theory explains the rising, whether it is a continuous or a discontinuous phenomena. There is a break in between. That's how parallel ranges are formed. Because it's not very easy for the plates to move, subduct and create continuous huge landform. So once a landmass is formed, this will be pushed away and subduction will be slightly away. A rift valley will be formed. Then subduction will be there and then parallel ranges will be formed.
So this whole process is going on in asthenosphere or mantle?
Mantle is asthenosphere is a part of mantle. When we say mantle, that is older one. Part of lithosphere, lower part of lithosphere, plus asthenosphere, plus mesosphere, all these three are mantle. So when we say asthenosphere, it's not only asthenosphere, it depends upon the strength of the subducting plate that will occupy the area and the depth of the earthquake in a particular region tells you about the depth of the subduction. The deepest recorded earthquake is found in Chile. Recorded earthquake. There may be deeper earthquake than that. That's 720 kilometers deep. And you look at here, 100 to 200 kilometers asthenosphere. Right? So beyond 500 kilometers below asthenosphere it has reached. Only then the possibility of that earthquake is there. Right? Next, the convergence is classified or divided into three types depending upon the type of plate involved along the line of the convergence. Right? It may be number one, ocean continent convergence. It may be ocean convergence and it may be continent convergence. The common consequences along all these convergence includes number one, subduction, number two, formation of sediments, number three, formation of a depression, number four, upliftment of the area, number five, occurrence of the earthquake, number six, volcanic phenomena, these are the common consequences of all the convergence. However, the consequences may differ not only in its shape but also in its intensity. And magnitude. Here the intensity and magnitude is not that earthquake terms, it's literal in English term.
That was his question.
Not single depression. There are multiple depression which is not.
Which will join? Depression will join.
Just like that's why I showed you that African Rift Valley. Right now it is what? In the form of different discontinuous rift. But there is a continuation of the upper part which can be demarcated. Fine, here we are going to join. So that's since a very long process. So wherever the magma rises, magma rising is a subject of different perspective. Magma rises depending upon the position in the asthenosphere, then the lithosphere. If the magma starts rising, initially they'll find the easiest way to come up. So once they have formed Rift Valley here and there, it may not be continuous initially. So they will form here, there and there. After they are continuously encroaching it, both the sides will be encroached upon. And gradually they'll join together to form a single Rift Valley. Okay? Any more question? Now, how this may be a different question also. The difference in the intensity of earthquake and volcanism along the convergent boundary, or discuss the consequences of convergent boundary. So if the question is about simple consequences, you can talk about the common and separate consequences. The intensity of earthquake and volcanism will differ. The intensity of folding will differ. The depth of the, like for example, why the deepest trenches are formed in the Pacific Ocean, and it's not there in the Atlantic, is in the along the ocean boundary rather than the ocean continent. Right? If you look at the folding, Japan is also a consequence of a convergent boundary, but the fold, that's not called fold mountains. Why they are called island arcs? Right? If the folding, if you look at why Himalaya is the highest mountain, not the Andes and the Rockies. So height of the mountain, the intensity of the folding, the nature of folding, the depth of the trenches, the height of the plateau, all will differ in different types of convergence. Like why Tibetan plateau is the highest and not the Bolivia plateau, not the Patagonia plateau and all. Hope we understand that. Question. So if the question is asked in this manner, you should handle accordingly. Though the conceptual clarity will be in one go, but we'll keep on talking about the different perspective. Let's first start with the ocean-ocean convergence. Ocean-continent convergence. That's easier to understand. When the two plates converge, one plate moves down or subduct. Here, the subducting plate is the oceanic plate because of higher density. The subducting plate will produce, or rather the compressive force or the compression will produce sediments which will be further increased by the exogenetic forces working over the continental areas. The sediments will be crumpled, squeezed into a fold structure. The subducting plate will bend to move underneath the continental plate. To make a trench near the continent. The magma produced will push the structure, that is folded structure, upward to increase the height of the mountain. And nearby areas will be pushed to form plateau away from the mountain over the continent. All the mountains, what is this? All the mountains along the coastal areas are explained through this mechanism. The rising magma may find its way till the top of the mountain. Since the distance traveled by these magma is much higher, their chemical composition changes into what we call andesitic, after the name of the Andes mountain. For example, Mount Cotopaxi, Ojos del Salado. ये क्या है इसका इन्वर्टर का, तो उधर से लाइट ऑफ कर दो. Which one? Mount Cotopaxi, Ojos del Salado. Ojos del Salado is the highest volcano on the surface of the earth, and Cotopaxi is the highest active volcano on the surface of the earth. उधर की भी लाइट ऑफ कर दो सब कुछ.
Is it inactive or extinct?
It's active, not active. Not dormant. Right? Hopefully we understand this part. A trench formation, a fold mountain formation, and the plateaus away from it. When you are writing about plateau, you can give example of Patagonia, Bolivia Plateau in the Andes Mountain. Then you can talk about Colorado Plateau, Columbia Plateau. Columbia is basically a volcanic plateau, but that's also uplifted. Ocean collision. The convergence or such convergence takes place under the ocean water the amount of sedimentary rocks produced are minimum. Because of higher density of the plates involved in the convergence and the absence of the exogenic or exogenically produced sediments. Hence, the folding is almost absent. The subduction is complex as the density as two plates with similar density are lined up in the convergence zone. Hence, pressure dependent upon the size of the plate and the forces along the divergence determines the plate of subduction. the bending of the plate, bending of the subducting plate is very sharp. Hence, the deepest trenches are formed along this boundary. The magma produced pushing the structure have two consequences. The marginal part undergoing compression is uplifted to form island arc seamounts, abyssal hills. Second is uplifted part away from the islands make shallow water zones to form important fishing grounds of the world.
Sedimentary rocks are not formed in this region.
Two oceanic plates colliding against each other. Both are high density rocks. It's not that not formed, but the amount will be very less, and that explains the intensity of folding also. Because if you have sedimentary rocks produced in between, for example, a towel can be easily compressed as compared to maybe iron sheet, aluminum sheet. So that can explain, first, the formation of sedimentary rocks will be less because the density of the converging plates are high. Second, there is no exogenetic forces working upon it because convergence is taking place under the ocean water, unlike the case of ocean continent convergence, because one is continent, so wherever convergence is taking place, lot of sedimentary rocks will be supplied from the exogenetic forces from the continental areas, right? So the amount of sedimentary rocks will be higher in the case of ocean continent convergence as compared to ocean ocean convergence.
So what thickness has to do with sediments?
Sorry,
The density, more denser.
like look at here, let the two dias collide against each other. Let the dias collide against chair, right? So broken pieces will be more in this case if it is fragile, and in less in this case, least in this case, number one. Number two, when ocean continents collide, river must be here, water must be here, then air must be, wind must be here, maybe glaciers are also here. So exogenetic forces will keep on, and look at it as a million years phenomena. Like Himalaya has been formed around 100 million years. So even a small amount of sediments on daily basis supplied from the exogenetic forces will accumulate in huge supply of sediments, right? And the sediments which are brought from the continent by exogenetic forces are smaller in pieces, which can be easily crumpled, crushed, folded to form the coastal mountain.
That's why Japan is not called a fold mountain. But the process and the normal consequences is very much similar to that of a fold mountain. If you look at the economic consequences, so economic consequences is similar that of mountainous region, where there will be relative absence of the heavy metallic minerals, right, where there will be relative absence of other resources also. Since sedimentary rocks are not there, they are relatively flat areas, but the soil formation will be very tough. That's why Japan doesn't have enough amount of plain area. Hence, agriculture cannot be a basis for their sustenance. So they had to look out for other sectoral development. That's why industry services are a more important activity in an area like Japan as compared to other islands also.
So that's the reason maybe they also occupied the eastern part of
China, yes. That's why they got involved into China and the First World Wars. You can explain from geographical perspective also. Man's necessity forces them to do whatever nonsense is possible. 4 दिन आप भूखा रख करके किसी को एथिक्स इंटीग्रिटी को आप फॉलो करने के लिए फोर्स नहीं कर सकते. द सेम इज हैपनिंग इन डिमोनेटाइजेशन ऑल्सो. द लेवल ऑफ इम्प्लीमेंटेशन हैज डेफिनेटली बीन पुअर. एज एन आइडिया इट मे बी ग्रेट एंड मे नॉट बी ग्रेट, दैट इज डिबेटेबल. But as far as the implementation is concerned, the way people are queued up along the banking sectors, for the people who are relatively well off, they can somehow manage. Like if I want to go and tell some grocery shoppers कि भाई अगले महीने का मुझे दे दो, जब तक पैसे नहीं आएंगे मैं दूंगा नहीं. They'll be happily doing it because they were very secure that ठीक है fine सर हैं तो दे ही देंगे. Imagine the same about the daily wages, the labor class. वो लास्ट में आकर के आपको तंग करेंगे ही. पुलिस वालों को मारना शुरू कर दिए हैं. So if that continuously goes on, that may create much more havoc for the society. So humans are उसमें कितने भी civilized आपको होंगे, completely non-violent होंगे, but जब पेट पे लात पड़ती है ना, तो सारी चीज़ लोग भूल जाते हैं. The same is about world wars also. Can be explained through economic perspective, which is definitely dependent on geographical perspective. इंसान कोई बुरा कोई अच्छा नहीं होता है, उसको वो हालात का गुलाम होता है. वक्त और हालात किसी को कुछ भी बना सकता है. नहीं, हम लोगों को भी क्रिमिनल बना सकता है. 4 दिन इस कमरे में बंद रखा जाए किसी न किसी वजह से, आज की डेट में 5वें दिन हम लोग निकलेंगे तो सबसे पहला काम ये होगा किसको लूटा जाए खाने के लिए. पैसे से दे रहे हो तो भाई दे दो, नहीं दे रहे हो तो फिर उस वक्त भागते हुए ये भी नहीं सोचेंगे कौन गर्ल्स है, कौन बॉयज़ है, कौन सर हैं, कौन मैडम है, कौन स्टूडेंट है, सब रिश्ते भूल जाएंगे. द फर्स्ट थिंग विल बी टू गेट दी फूड. तो इकोनॉमी इज द फंडामेंटल रीजन. So the magma produced is resulting into upliftment. Besides, the number of volcanoes will be highest on the top of the island arcs, as the magma has to pass through relatively thinner upper part, that is oceanic crust. The magnitude of the earthquake may be higher and the foci may be very deep, very often resulting into tsunami as well. Hope it is clear. Continent collision.
Sir, is there any role of density of the crust also? Like oceanic crust is of basaltic rock, which is
Denser.
than quartz and feldspar. And doesn't it play a role in the eruption of magma?
No, it will play a role, but look at here, when magma comes, it doesn't come by force, it more comes because of temperature. So it can melt, right? But what happens in the case of continent, for example, there is a complete absence of volcanic eruption on Himalayas, right? How will you explain that? The only possible explanation is the depth through which magma is supposed to travel. Now, when the magma is traveling away from the source of magma, in the process it keeps on reducing temperature also. When the temperature is reduced, its ability to move upward also reduces. So the relatively thinner oceanic crust is easier for the magma to cross. And even when it is uplifted, the upliftment is fundamentally associated with the rise of magma, remember it. Right? So don't look at the top of Japan from the present perspective. Look at the Japan must have been rising with the help of the magmatic upwelling also. So they have to pass through relatively thinner oceanic crust. So once they have reached on the top, they will keep on flowing. So even if the top is rising and has become like islands and above the sea level, the magma will keep on intruding through that. That's why number of volcanic peaks will be highest in the case of ocean-ocean collision, less in the case of ocean-continent collision, and least in the case of continent-continent collision. Clear hai? Right? Now the continent, when two continents collide against each other, that is when two continents collides against each other, the situation is far more complex than the other two types. The collision follows the ocean continent collision, as before the two continents come close, they must have oceans in between them. Once the ocean disappears, they collide. One of the continental plate must be attached to the subducting oceanic plate, which is dragged by it. Underneath the other continental plate. This results into disappearance of the sea oceans, formation of an intracontinental fold mountain a huge plateau on the other side, whereas the depression gets transformed into a plain through continuous sedimentation. Thus there is an absence of the trench high intensity of folding associated with maximum possible amount of sediments brought not only from the collision of two lighter continental plates, but also supplied from both sides of the continents by exogenetic forces. The continent dragged by the subducting oceanic plate makes a double layer in the region. This causes huge increase in height of the mountain. The higher depth of continents makes it tough for the magma formed inside to reach the top. This explains a general absence of volcanic peak along such mountains. However, the post-volcanic phenomena like geysers, hot springs, etc. may be present. it is believed that the subduction is either improper or altogether absent in continent collision. As the oceanic plate subducts independently after a point of time, leaving the continental part underneath the fold mountain.
It's always mandatory to have a ocean continent collision before continent continent.
Has to be. Imagine two continents are lying. So obviously for the collision to take place, there must be something in between. For example, for me and you to collide, let's assume that we are two continents. So there are people in the middle. If we are very close, then no collision at all. So first these two continents have to collide. So before that they must be separated. And if the possibility of separation is there, so what will be separating it? Only the oceanic plate. So before the two continents come close to each other, that oceanic plate which is separating it must disappear from. That's what in the case of Himalaya, Tethys Sea was there. Right? Tethys Sea disappeared. Then you have Indian plates colliding against the Eurasian plate. And that's why you have Himalayan mountain and Trans-Himalayan mountain. Right? When we go for physiographic divisions, so first the northern mountains will be there, and that northern mountains will be further divided into Trans-Himalayan mountain and Himalayan mountain. Right? In continuation of that, the collision site first produces an elongated valley called suture zone. For example, Indus Sangpo suture zone in the case of Himalaya, or the collision site of Indian and Eurasian plate. Indus, Sangpo. The Sangpo, Brahmaputra is known as Sangpo in Tibetan areas. Suture zone. Suture means stitching. So the two continents get stitched against each other. And that is the outer boundary of the main Himalayas.
Continent dragged by the subducting ocean plate makes a double layer in the region. Because there's a continent, ocean plate, and underneath that there's a continental plate.
No, the first thing is that when the two continents collides, both are of similar density. Similar case that of ocean-ocean collision. So the which plate will move under is determined by the fact that which continental areas or continental part was attached with the subducting oceanic plate. Right. In the case of, let's say, suppose this is the case of Tethys Sea. So Tethys plate is there, then this side you have Indian plate and this side you have Eurasian plate. So if the Indian plate is attached with the Tethys Sea plate, once the Tethys Sea is consumed, this is the case of ocean-continent collision, then you will have the continent-continent collision. So once oceanic plate is completely consumed, now it will be colliding. So this plate will be dragged inside by the subducting oceanic plate. Right. That's why the trench which was earlier formed, when there is a collision of ocean continent, there must be trench formation. So the continent which is subducting will initially fill that trench, but that will not be completely filled because the trench is a very deep area. That will be further added by lots of sedimentary rocks brought from the two continental areas to transform into a Ganga plain. That's why where it is bending, Indian plate where it's bending, it's called Vindhyan scarps. What is a scarp? A landform, one side is steep, another side is jolting. So that is the site of the convergence. From here it is converging and it reaches up till the Indus Sangpo suture zone. And that's why whenever one range is formed, there will be shifting of that. Another range will be formed, there will be shifting, bending, further bending. And that's how we have three parallel ranges of Himalayas.
How is the height so much?
Again, the continent is moving under a continent. So that's why double layering of the continent. Tibetan plateau or Eurasian plate, that is continental area. Now Indian plate is moving under, so you have double layer of continents. That's known as double layer. And the continental plates are made up of possibly the lightest mineral. So once the oceanic plate is moving, it is moving under its own weight and they are relatively denser. So the movement will be relatively smooth. Obviously not smooth, but relatively smooth as compared to when the continental rocks wants to go enter into it. So it will be very difficult for the continental rocks to move and pierce the tough and denser rocks of mantle. So after a point of time that will be broken and the oceanic plate will move independently and there will not be subduction of the continental plate.
Sir, is there the reason for the difference in heights in Shivalik and Ladakh range?
It's Ladakh range.
Shivalik last range. Shivalik. Is it the reason the difference of heights, peaks?
No, Ladakh range, Karakoram range, Kailash range, not Zanskar. Zanskar is very wrongly put in many books. Zanskar is integral part of Himalaya. Very often it is put into Trans-Himalaya. Now, the most important symbol of understanding Himalaya and Trans-Himalaya is Indus Sangpo suture zone. The zone or the valley through which Indus flows and Sangpo flows. Anything to south means it is a continent origin. Anything to north means it is an ocean continent origin. So the moment we talk about Karakoram range, it is a product of ocean continent collision. Ladakh range, ocean continent collision. Right? Great Himalaya, Middle Himalaya, Shivaliks, all are, or for that matter, it is believed that Bhabhar region is the fourth range of Himalaya which is being formed. So that is, all the four ranges are the product of continent-continent collision.
So both the Americas are from ocean and continental.
Ocean or continental plate, yes.
So then why is the height of Andes almost 7 kilometers?
Andes is
7 kilometers. 7,000.
only. What's your question?
So I am asking it is still very high.
Yeah, definitely very high. They are mountains.
So they are mountain, but in the case of Himalayas, so it is double layer because of oceanic temperature. So then why is it in the case of Andes?
So Himalaya is 9 kilometer. The highest is roughly around 9 kilometer. 8800 is roughly 9 kilometer. And Andes is highest is around 7 kilometer. So can you differentiate between 7 kilometer and 9 kilometer? 2 kilometer is a big difference in the highest. Right? Just like right now, you see the Alps mountain along the European Mediterranean coast. So Alps are produced basically because of, you can see that's a very good example happening, what would have happened in the case of Himalaya. You open the atlas and look at the world map. Now look at the Mediterranean Sea. Right there you have the formation of Alps mountain along the margin. Now assume that the entire Mediterranean Sea is consumed gradually, sinking under the Alps mountain. So the height of Alps mountain will keep on increasing, hardly 2000 and 2500 meter right now. Alps. So the height will keep on increasing. So that is a product of ocean continent collision. Now once the entire Mediterranean Sea is consumed, which may take millions of years, it is the turn of the African plate to collide against Eurasian plate. Then there will be formation of Himalaya-like mountain. So it will be the Himalaya-like mountain after Africa collides against Eurasia, and the Alps will be called Trans-Himalayan mountain. So there will be a series of mountain which is now being produced. Alps is relatively smaller, so the second range is not being produced. Just imagine Alps of 2500 meter. So lots of sediments must have been coming through landslides, river erosion, wind erosion, glaciers, and would have been depositing in the oceanic area, right, along the foot of the Alps mountain. Now that will be folded again. When sediments are deposited, it relatively reduces the movement of speed of the plate. So the second parallel ranges will be created, which will be of lower height than this one. After that is produced and oceanic area is covered, then third parallel range might be created. And once it moves away, Africa comes close, then Africa starts sinking, and you have the continent collision. That's what would have happened in the case of Death Sea, what is happening today in the case of Mediterranean Sea. Look at large number of volcano along the periphery of that is indication of the subduction. Stromboli, Etna, lots of mountains, volcanic eruptions are there along the islands, along the under the ocean water.